Okay, are we ready? Thank you all so much for being here, especially given the weather situation and the dire warnings that we got. And it's just amazing to see such a big turnout for what is, for us at Okanagan Land Trust, a very special edition of our OkaKnowledgy speaker series. Those of you from the South County know we typically do those down at the Okanagan PUD, but for tonight and our topic, it felt appropriate to be here at the CCC. So I want to thank the CCC for that wonderful dinner. I hope most people got to eat. I think we took them by surprise with the number of diners and attendees. I have been asked to tell you that there is a membership meeting for the CCC membership meeting on March 21st, and you're encouraged to be there. They need the support and the energy of all those voices and people there, and again, just want to thank them for the space and the wonderful, warm atmosphere that they create. Well, that's about it. So my job right now is simply to welcome our first speaker tonight, Julie Vanderwal, a certified ecological restoration practitioner and owner of Sparrow Song Consulting. And really the thread that has run through this entire project, the whole lifespan of this project, and kept it all together and moving forward. So she's here to tell you about the reason that we're all here, and welcome, Julie.
Thank you so much. It's really special to be back at the CCC and to see these familiar faces. I can't tell you how much I love this. Thank you. I couldn't come without a song, it wouldn't be right. So, I would say I'll probably continue working on the song. This is my first time sharing it, and it might have like another verse in the end, but this is kind of the debut, I guess. And the most challenging melody I ever wrote, I don't know why I did that to myself, and I'm going to sing it a cappella because I don't have an accompaniment for it yet. So this is a challenge. What if you found a wetland that was really like no other wetland? Oh, what if you had a premonition that it would have calcareous conditions? And what if when you brought a team of plant nerds, you started hearing all of the key words like alkaline and fen, groundwater fed and mineral rich, like sensitive and rare, imperiled and unique, like irreplaceable and high priority. What would you do? What would you do? Would you let it get sold in a bunch of pieces with a cabin on each one? Or would you get together and keep it whole and let the wildlife run? Would you pull your people together, form a plan of attack? Cause if you let it get sold in a bunch of pieces, we'll never get it back. We'll never get it back. So what will you do? What will you do? Thank you. I don't really know where that one came from. I was driving down the road and the melody was just there, and I was like, oh, that's an interesting melody. Okay, but I need a Bonaparte Meadows song, so okay. There it is. Thank you. Gosh, it's just so great to be in this space. And I'm sure that many of us in the room have driven down Bonaparte Lake Road on the way to Bonaparte Lake, maybe from Tonasket, and looked over to the left, you know, when you're headed toward the lake, and you see this giant wetland. And many of us have wondered, what is the story with this wetland? And will there ever be an opportunity to protect it and restore it? And I am so excited to tell you that that time is now. And we just have a short window. Thank you. Yeah, and it's really exciting. We have this short window to work with that we're going to tell you about today. And first, I just want to share about why this wetland is so special. This is our plan for the evening. Oh, I actually made a mistake. I was doing a very quick edit because Josh can't make it. And I subbed in George's name because George Thornton is here. Let's give George a warm welcome. And at the very last minute, Josh couldn't make it. And we tried setting up 4 different sound systems to get the Zoom to play through the speakers, and we couldn't get it to work. And so at the very last minute, I shared Josh's notes with George. I said, George, thank you so much for coming to this event. We really appreciate you driving across the whole state just to be here. And how would you feel about sharing Josh's presentation tonight? And so George said yes, in a manner of speaking. And thank you so much. So this is our new plan. I'm going to talk about what makes Bonaparte Meadows special, and then Kate will talk about our campaign to protect the wetland and surrounding upland. And then Dana Visalli is here to talk about the improbable ecological dynamics that combined to create Bonaparte Meadows. And then we're going to hear about the wetland conditions. And honestly, George was out there in the wetland with us last summer, so anything he wants to tell us about his observations will be valuable. He spent so much time in wetlands in this region. It's amazing to have him here. So, I think I know a lot of the people in the room, but I'm Julie Vanderwal, and I love working with people like George, Josh, and Dana, protecting our wetlands and figuring out how to restore them when they're degraded. So, let's look at Bonaparte Meadows. It is just gorgeous. Is there anything more beautiful? This is looking from the overlook above Bonaparte Lake, looking south into the wetland. It's just incredible that we have this jewel in our region. Sometimes we don't realize how lucky we are. We have a number of very special wetlands, and this is the largest peat wetland in Okanagan County. It's huge. It's 260 acres. And just looking at the location of it, I'm sure most of you know kind of roughly where it is, but in case you don't, within the state and within the county, this is where it's located, in the corner. But you have a pointer right there. And looking at the neighboring towns, it's just almost halfway between Wakanda and Havila as the crow flies. I don't know how many crows fly that way straight across the mountain, but this is the conservation acquisition that we're working on, and it's 745 acres together because it's the upland forest as well as the wetland. So it's a large area, and it's surrounded by public lands. So in the conservation world, we're always trying to figure out how can we create continuity, connectivity. How can we have wide open spaces for wildlife to be able to freely move? Well, how often do we get the opportunity to protect a property that's surrounded by public land? I mean, it's just adding to that continuity of open space. So it's really well situated with both the National Forest and the Department of Natural Resources lands around it. And it has a history of peat extraction. This is a photo taken in the 40s, and you can actually see these little rectangles. To me, that looks like peat extraction. I don't have any documents to prove it, but the picture looks like it. And then from the early 80s through till 2023, a little bit in 2024, peat was extracted from the wetland. And you can see the, oops, sorry, I'm getting shaky up here. You can see the places where the peat was extracted. So there's areas that are disturbed and degraded, but then there's also areas that are intact and functional and in really good shape. So we have both a great opportunity for restoration and preservation. There's parts of this wetland that are worth, if we protect them today, that's the best thing we can do and just ensure that they're not degraded. And then there's parts we can start the restoration process on in the future. So why do we want to protect Bonaparte Meadows? Well, water storage is a big one, and it's one we can all relate to. No matter how you see things in this world, we all need water. And we need clean water, and we need enough of it for everybody. It's just one of those common ground things you can talk about. No one's going to argue on that, right? Like, no, I don't need water. We all need it. And when we have wetlands, they're able to hold water. And when we have high flows and lots of rain in the spring, and we're rich with water, if there are wetlands that are healthy on the landscape, they will soak up that water and hold it, and then let it out into the streams, recharge the groundwater in times when water is scarce. So wetlands are they're our ticket to being able to store water on the landscape naturally, a nature-based solution instead of like a reservoir, for example. It's a natural reservoir. And we have Bonaparte Creek flowing out of the wetland that benefits from this wetland because it's groundwater fed, as you heard in the song. And so that cold groundwater is coming into the wetland and then it's being released into the creek. And so the healthier this wetland is, the better able it will be to augment the flows in the dry parts of the season. And wetlands are just really important for climate resilience in general. Think about droughts, floods, wildfires, things that we all are concerned about that we've all had to deal with. When we have a large wetland that we're able to protect and restore and get it as functional as possible, that is our opportunity for climate resilience in all three of those areas: floods, drought, and wildfire. And then we have carbon storage. You know, it's getting more and more important that we figure out how to keep carbon in the ground rather than in the atmosphere. And this is a peat wetland, as we know, from the peat extraction that we talked about. And peat wetlands are really unique because they cover only 3% of the Earth's surface. So we're talking about a very small area. And yet they store 30% of all the carbon that's stored on land. Another way to look at it is that they store twice as much carbon as any other ecotype. So they're small but mighty. And in that small area, you can store a lot of carbon. If you remove the peat, then that carbon gets released into the atmosphere, and it has the opposite effect. It's damaging. It's more carbon in the atmosphere. So really important opportunity for us to keep carbon in the ground. And then the biodiversity. This was a really exciting part of learning more about Bonaparte Meadows because for the first year or two that I was looking into Bonaparte Meadows, we didn't have the chance to be out on the ground yet. And so we were guessing, I was thinking it's probably going to be a calcareous fen because it's probably groundwater fed, and we know that the bedrock is really calcium rich, right? That limestone, and when the water moves over the limestone, it picks up all kinds of minerals, and it creates a completely different chemistry in the wetland. And so we had all these guesses about the plants that we thought were going to be in there, and what the pH of the water might be, the electrical conductivity of the water. And sure enough, once we got in there, it was a calcareous fen, which is the rarest type of wetland, one of the rarest types of wetlands in the United States. Very rare and special wetland. And because of that water that's mineral rich, you get plants that can only grow in really specific conditions. So the biodiversity is amazing. And we had different people who were helping. I feel like I just missed a slide. We had different people who were helping with the botany surveys. We did 3 botany surveys last summer, and spring, summer, fall. And different volunteers, community members, people from different agencies. This is George Thornton and Dana Visalli looking at the willows. There's an incredible stand of native willows, including some rare willows. We had Erica Henlin, Joe Rocchio, Mac from the Forest Service, all kinds of really skillful people sharing their expertise. And we found 4 plants that are sensitive and critically imperiled, plus 2 that are on the review list for potentially being ranked as sensitive and critically imperiled. We found 1 plant species that is sensitive and vulnerable, and 1 that's under review to be ranked as sensitive and imperiled. So 8 different plant species that are sensitive and rare growing in Bonaparte Meadows because of those conditions. Because usually peat wetlands are acidic, right? You think of a bog, it's acidic. But this isn't a bog, it's a fen. It's groundwater fed, it's not fed by rain and surface water. And because of that limestone and the minerals in the water, it's alkaline, and so it's just really unique things that we found there. We also found this adorable Columbia spotted frog who really did not want his picture taken. I'm so sorry, little guy. We put him back in the water right after we took the picture. But Columbia spotted frogs are a candidate species for listing under the Endangered Species Act. And there are lots of them. We don't know the abundance yet. In fact, there's an expert who's going to come and do an amphibian survey this spring through a connection with the Okanagan Beaver Project. Thank you, Alexa, and Gert Webster, who helped make that connection. And so she's going to come out, and some community members are helping keep us informed about the conditions so that we're going to know right when the time is for her to travel up here. And she's going to help us figure out more about the abundance as well, so we know how many of each species, and then also maybe some species that we haven't seen before that she will be able to find. So that's really exciting. Some of the plants that we found that are sensitive and rare are also very beautiful. And we didn't find just a few of this plant. We found like a patch that was at least a quarter of an acre. I mean, mainly that rare plant. Really, really surprising. And then just, butterflies, different pollinators that we found along the way. Just a lot of biodiversity. And then the mammals. I mean, you can picture anything from elk to Canada lynx. We've got deer. We've got all kinds of mammals. And then birds. We're going to do bird surveys this spring. Michelle's in the house somewhere. Yes. We're going to be doing some bird surveys so we get to find out more about the specific birds that are there. We have a list from the landowner that's very extensive. So we know the bird diversity is really impressive as well. And then open space. Another reason to protect Bonaparte Meadows is just like we looked at that map with public lands all around, and then being able to keep this space open rather than having it be broken down into parcels with a cabin on each one so people can visit Bonaparte Lake. I mean, that would be compelling for folks, right? Of course, we all want to go to Bonaparte Lake. It's beautiful. But we don't want to subdivide Bonaparte Meadows and see cabins all over it. We would never be able to get this open space back. So that's a big reason to protect it right now where we can. This is a whole colony of coltsfoot, a native wetland plant. Just beautiful. And then the opportunities for community engagement, involvement, education are incredible because, I keep saying incredible, I'm sorry, it's hard not to keep saying that word. The road runs right along the wetlands, so the access is amazing. I mean, so many times these wetlands, you'd have to hike over a bunch of fallen trees for an hour and hope you don't break your leg, and maybe you'll get to see that wetland if you're really dedicated and in really good shape. But what if maybe you don't have that kind of mobility? What if you can't hike in really difficult conditions? Well, you could still come and see Bonaparte Meadows because you would just go right down off the road and you'd be there in the wetland. So the access provides this unique opportunity for people to be involved. People could do birding by ear even if they were in a wheelchair. And they would get to hear some really cool species and see some really cool species with a scope too. So there's a lot of accessibility for a wide variety of different people of different abilities physically to just be a part of a really special site and learn from it and learn about it and contribute to our understanding of it through citizen science. And then there are the restoration opportunities. So the other reason to protect Bonaparte Meadows is so that we can restore it, because there's a lot of people who are interested in restoring it, actually. That's kind of the place where we found the most enthusiasm, where people would be willing to donate funds, for example. But we're never going to get to restore it if we don't acquire it first. So it's very important we take this step and protect the land so that we then have that opportunity to restore the places where it is degraded. And in order to extract the peat out of the wetland, there are these channels that have been dredged and they're straight as can be. That's what we call efficient conveyance of water, and it's the opposite of what we want in restoration. We do not want efficient conveyance of water off of the site. We want the water to slow down, and spread out, and spend some time on the site before it leaves. So this is a place where we could remediate this situation so that the water is no longer leaving the site so quickly. And we want to raise that water table back up because that water table was strategically lowered in order to facilitate peat extraction. And that affected the whole wetland. Even though there's parts of the wetland that are still intact, in really good shape and are functional, we still noticed in the plant community that there were shifts that had occurred because the water table was lowered. So even in a place that didn't appear degraded, we were looking at plant species like Baltic rush, which is just very hardy, can kind of grow anywhere, where we would have otherwise maybe seen some sensitive sedges like calcareous magellanica, which we didn't see at all on the site, and I thought maybe we would. So I think that as we raise the water table and restore the whole site, there's going to be some other sensitive plant species that start showing up. So there's a lot of opportunity with restoration. This is a picture from Mary, showing this is one of the peat extraction areas where restoration is needed. So lots of reasons to protect Bonaparte Meadows, lots of opportunities for people to be involved and help out. These are some students from Western Washington University who came out last summer, and they're with Joe Rocchio, who is like the rock star of calcareous fens. He's the program manager for the DNR's Natural Heritage Program. That's the program that designates which species should be considered sensitive, rare, imperiled. So having him on site was super special. Same thing, having Erica Henlin on site was really special. She had already done a study of Bonaparte Meadows in the year 2000 as part of her master's work, and so she was coming back to it after that time had gone by, and just having those eyes on the ground and then combined with students who are just starting out. It's really exciting, you know, it's like intergenerational knowledge sharing, and there's just so much room for that to happen at Bonaparte Meadows. So those are all the reasons why we believe we should be protecting Bonaparte Meadows. There's more reasons too, but those are the main ones. Here's some contact info in case you want to reach out to Kate or I, and also some links where you can find content about this project online on Facebook or Instagram. And I want to welcome Kate back up to talk about the campaign to protect Bonaparte Meadows. How are we doing this? How are we going to go about it?
Yes, so I think I failed to introduce myself earlier, but I am Kate Miller. I'm Executive Director of Okanagan Land Trust, and yes, I'm here to tell you a little bit about the plan. What are we going to do about all these amazing conservation values and benefits that are here to be protected? So my recollection of how I got and OLT got involved in this project is that about 2 years ago, or even a bit more, I started getting phone calls. Some from folks like Julie, fellow conservation people, and some from neighbors and sort of local naturalists there in the Wakanda and Highlands area. And from those just conversations and phone calls and meetings, this kind of groundswell of, you know, this place is amazing, what can we do? And many people, in fact, have been waiting and watching for decades, in some cases, for the opportunity for this land to come on the market and the opportunity to be there to protect it. So through this networking, through these conversations, we kind of grew into a loose coalition of partners who I'll talk about in a moment. And that coalition tried various strategies, looked at different ways to acquire the land as a first step to begin long-term protection and restoration and stewardship. Okanagan Conservation District was sort of in the lead position for a while there, the Confederated Tribes of the Colville Reservation, other partners. And eventually we landed on the idea that to protect this wetland, to acquire it, was going to take effectively a strategy that land trusts specialize in, a private land acquisition. And our strategy at this time is to use a combination of state grants and private fundraising as the match for those grants. So that is the plan, that is the strategy. We have an appraisal on the property thanks to the generosity of one of our partners, Trout Unlimited, so we know roughly the acquisition cost. And from there we have a budget, we've built a budget of about $3 million to complete the entire transaction. Which again, we're gonna raise more or less half and half, so roughly 1.5 million in grants, 1.5 million then in private fundraising to match. So here we are, that's what we are at the start of that campaign to raise that private money, and in the meantime, we are pursuing those grant opportunities to make up the difference. So I just wanna recognize, acknowledge, and thank the many partners that have come together with OLT to do this. I mentioned Fish and Wildlife Program staff from the Confederated Tribes of the Colville Reservation being really key and sort of early partners in this effort. Trout Unlimited, you're going to hear from Mike Ward in just a moment. Their interest being primarily in the restoration for fish and other aquatic habitat benefits. And Okanagan Conservation District has been right there in the mix since the beginning as well. But many others have kind of come on board and lent their support in various ways as the campaign has gathered momentum. So Okanagan Highlands Alliance, Jen is here somewhere today, have been amazing in all kinds of ways. The North Central Washington Audubon chapter has jumped in. So part of, I think, in addition to everything that Julie just told you, part of how we know that this effort is both worth pursuing and attainable, this goal, right, is just how many incredible individuals and organizations have jumped on board to support the effort. I also would like to thank briefly and acknowledge the landowners who are giving us this opportunity in the first place. They're not necessarily conservationists. I don't think they would call themselves environmentalists, but the late landowner Jack Jones told his sons, his heirs, that he hoped that the property could stay intact when they passed it on. And that has given us our opportunity because we are the buyer most likely to keep it in that condition. So it's given us this window through July 31st to give it our best shot and acquire the land. I moved on more quickly than I intended to. Mike, do you want to say a few words on behalf of Trout Unlimited?
Sure.
Yes, please.
Hi, everybody. Like Julie, there's lots of familiar faces here. I'm very happy to be here in the capacity of standing in front of y'all and talking about Bonaparte Meadows. I have been in the Wakanda and Tonasket area for about 30 years now, and mostly worked as a fisheries ecologist and consulting. But a couple years ago, I had the opportunity to switch over to Trout Unlimited and work for them as a project manager. I told them I'm only going to work on one project, but then this one came along, so now I'm working on 2 projects. And super happy to be helping protect something that's in literally my backyard, and it's where my daughter was born and growing up so far, and happy to have this chance. So Trout Unlimited is a nationwide organization that is dedicated to protecting and conserving cold water habitat, primarily for fish, salmon, and trout, but other conservation issues too. It has about 300,000 members nationwide. About 50 of them live here in Okanagan County, and you can think it's a lot of fly fishing anglers and folks that like to get outdoors that support us. We have about 350 staff people. I'm one of them, and most of the staff manages various restoration projects. And so we have dedicated funds to this project. I get to manage those. I helped with contracts and stuff that went into the appraisal and the land surveys and botany surveys so far up at the site, and we'll continue to manage a pool of money that can help advance this project. Another important thing that I can do is work on grants and help with the fundraising and bring money into the project. Today I had a chance to work with a scientist that works for Trout Unlimited. He knows a lot about peat wetlands and is going to bring his expertise to bear. We'll pull in other folks too. So we're going to have like a nationwide level of effort to bring to bear on this excellent project. So I guess that's about all I have to say. If anyone has questions, you see me around town and want to talk about Bonaparte Meadows, just wave me over. Thanks.
Yeah, I really thank you, Mike, and Trout Unlimited. I really want to thank all of our partners that I've mentioned. We wouldn't be at this stage with the opportunity ahead of us, without this kind of collaborative effort, and it's amazing to have that support continuing as we move towards acquisition. So I'm going to zoom through the rest of this pretty quickly so we can get to the good stuff with George and Dana's presentations. But I want to tell you a little bit about what it is we're trying to do here, what we're trying to raise. I mentioned that the private fundraising campaign, our goal is $1.5 million, or about half of the acquisition cost. We are starting this public phase of the campaign with $600,000 already raised. 400,000 of that, we're off to a strong start. 400,000 of that comes from Okanagan Land Trust's own Opportunity Fund. We really believe in this project and couldn't think of a better use for those funds. And we've received one major gift, and actually a number of major gifts so far, including a recent $10,000 gift from a local community member who wanted to remain anonymous but wanted me to share with you that that gift was, made in honor of or dedicated to the people who helped them out in a very difficult time in their lives, and the support from this community is what led them to want to make that major gift to the campaign. We also, I'm very excited to announce for the first time tonight, we have also now a $10,000 matching gift. So it is structured as a challenge to all of you, to everyone else. From now through the end of April, all gifts up to $100 will be matched one-to-one until we reach that $10,000 threshold. And the goal was really to encourage folks with smaller amounts to give to get in there and support the campaign. So starting now, any gifts up to $100 through the end of April will be matched one-to-one and double the value of what you can give. So, thank you for that. It's this kind of thing that just really helps us build momentum. So how you can help? You can support the campaign in any way that feels good and appropriate to you. If you have the capacity to make a major gift, meaning $10,000 or more, either all at once or spread out over up to a 3-year period, come and talk to me. We can talk about how to make that work and how to make it go as far as it can. Spread the word. You can help us make connections with people who can give at something like that level. You could host an event, a gathering. We'll show up and talk about the Fen and how great it is. So yeah, all kinds of ways that people in this room can help make this happen. And again, we have our deadline of the end of July of this year. It's a short time, but just the energy that has been unleashed already, the support that's here in this room, and in every conversation that we have about this opportunity, I know we're going to do it. So thank you so much for being here, and I'm going to turn it back over to the folks who are really here to hear from. Oh, can I answer questions about the campaign after Josh and Dana speak? We will have time for folks to ask any questions about donation methods or anything like that. Is that okay? Okay, I'll shut up now.
Well, I need to welcome Dana Visalli, who's next, to talk to us about how Bonaparte Meadows came to be. And if you want to come up, Dana, and I've got your slides loaded.
So I'm on? Thank you. Hi, folks. Nice to be here in your community. It's been a while since I've been here. So this is a bit of a wild card, I think, but it's sort of a evolutionary an ecological overview of life, really. It's not so much about Bonaparte Meadows. That is Bonaparte Meadows in that photo. And let's see if I can make those. I'm not sure if this is working properly. It'll function okay, but those red circles aren't supposed to be there until I invoke them. This doesn't matter. It doesn't matter in this slide, but it might matter in other slides a little bit. So, I know this is a leap. Well, for one thing, I put that line in there. It's a picture of the Milky Way galaxy from outside the galaxy. I don't know if you get it, but it's a joke. We cannot get outside of our galaxy. We can hardly get off the planet. So it's probably the Andromeda Galaxy, I'm not sure. It is a galaxy, it's a different galaxy, but it looks a lot like the Milky Way galaxy. And it's just a little transcendent, really, context. I really hadn't planned to say this, but my bed in Twist is up against the window, and I crack it open, and blinds are up. And lately, I've been waking up in the middle of the night and seeing those stars in the sky, and realizing that there are millions and millions of stars. People like to say there's more stars in the sky than there are sands on the oceans of the earth. And they're all burning something. Different stars burn different things. Mostly they burn hydrogen and helium. And they transform it into larger elements, and in the process, energy is given off. But it is transcendental. It really is. It's beyond our comprehension. I think I have a quote, but sorry. So I like big history. Big history is a academic subject taught in colleges. It's the evolutionary story of life on Earth, but it has this name, this nice, simple, easy to handle name called Big History. There is a big history to the Earth, and there's a big history to this area where we are, Okanagan County, the Okanagan Highlands, Bonaparte Lake. It all came from somewhere. None of it used to exist, and that's the fascinating part. Part of the origin of the Earth, of the elements that make up the Earth, are supernova explosions. When supernovas explode, they create the larger elements, things like, well, uranium's coming up. Uranium can't even hold itself together. It has so many protons in the nucleus that it can't hold itself together, so it spontaneously falls apart and creates energy and radiation. The sun, improbably, I really like that word for this whole spectrum of information. The sun is improbably fusing 600 million tons of hydrogen a second. And it's been doing it for 4 billion years. So we're into a realm that is beyond the capacity of the human mind to grasp. But the human mind has figured out that this is the case. This is what the stars are doing. They're fusing elements into larger elements. So I really like this quote. Unfortunately, I forget some physicist. The world is not only stranger than we think, it's stranger than we can think. And part of that strangeness is that energy and mass are interchangeable. That you can turn mass into energy and energy into mass, and it was Einstein who figured that out. All you have to do is multiply the mass by c squared. C is the speed of light. C is the speed of light, so c squared is the speed of light squared. So how did Einstein figure that out? Well, that's a cartoon that shows you how he figured it out. E equals m times a squared. Well, that can't be right. Well, mass equals m times b squared. Nah, that doesn't. Then he put E equals m times c squared, and that's it. That's how he figured out that mass and energy are interchangeable. It's a joke. Well, we know there are radioactive elements. Uranium is one of them. Uranium has 92 protons in the nucleus. Well, the protons are all, it's like trying to hold the positive charge of 92 magnets, push them all together at the same time. They don't want to be together. And so it spontaneous decays, spontaneously falls apart into smaller elements and gives off energy. And the reason I think that I brought this up, well, it's going to come out in a slide or two, why I'm talking about the fact that this energy is emitting from the core of the Earth, from radioactive decay. From the core and the mantle, there's radioactive elements that were formed in supernova explosions. That's how uranium was formed. The heat and the pressure of the explosion of a star created these radioactive elements that can't hold themselves together. It's time constrained. At some point in the evolution of the universe, they'll be gone. So this is the best image I could find to try and illustrate. The Earth is made out of these various elements. Happily, I can read. The red is oxygen. So this is the Earth's crust. 50% of the Earth's crust, that says 49% up there, I think, is oxygen. There's silicone, aluminum, iron, calcium. What I find fascinating is that the human body is made out of the same thing. We are made out of the crust of the earth. We are of the earth. There's no place else that humanity could have come from but from the earth itself. It's unnerving to think about it. So here's a product of that radioactive decay. The radioactive elements were created by supernova explosions, crammed all these protons together. Over time, they fall apart and give off energy. That's why the center of the earth is molten, due to radioactive decay. The heat rises and creates cracks in the surface of the earth that we call rift zones, and that thing should be moving, but it doesn't feel like moving, I guess. But the earth is covered with all these rift zones, and there's a picture of all those red lines. So in the center of the picture, it's a little hard to see at first. The center of the picture is North and South America in gray. And then the red is all in the oceans, but those are all rift zones where magma is actually rising from the Earth's core, driven by the heat of radioactive decay, and the radiation is from supernova explosions. So we're on an evolutionary journey here. The Earth is part of an evolutionary journey. The heat, as it rises, pushes the Earth's crust around. Now, you might wonder what this has to do with Tonasket. But part of the Okanagan Highlands is made up, I think it's, well, yeah, it says there at the bottom, is our island arcs. They're a certain type of rock that were embedded on the ocean crust. But as the heat rose and cracked the Earth's crust, the crust started to move, and it carried these island arcs towards the point where the crust was subducting under existing land, and the island arcs got pushed onto the land. So you can see in the second picture it says continental nucleus. The continent is starting to grow. The third picture, the continent's bigger still because of this accumulation of island arcs driven by radioactive decay. So, the Okanagan Highlands, are they composed of island arcs? Actually, I asked this of AI, and I don't know how many use AI, but I like AI. It really answers your questions. First, it says yes. If you ask, I just like the way it works. So this is what it said. Yes, the Okanagan Highlands are composed largely of accreted terrains, which are these island arcs that got pushed onto the continent. So the continent has accumulated over billions of years. There was not always a North American continent, South American continent. Well, I had to transition. There's not much time. So what happened? What else has happened? Well, the stunning thing is what does happen over time. That the Earth's crust rips apart and molten lava flows out. And then there have been repeated ice ages. It says 20 to 50 there. Glacial advances in the Pleistocene Ice Age, the last 2 million years, ice has repeatedly grown on the surface of North and South America and in Europe and some in Africa, and then retreated, and grown and retreated and grown and retreated. And that's a big part of what has shaped the land in Okanagan County. So we have this small problem with the origin of life. That little organism there, let's say a nanometer, that mycoplasma is 200 nanometers. I'm not really that great at this stuff. Nanometers are, I think you get it takes about 400 nanometers of width to be visible to the human eye, just to give you some sense of the size of a nanometer. So this bacteria, mycoplasma, is 200 nanometers. It's invisible. You can't see it. But look at the complexity of that organism. Somehow it created all of the dynamic structures necessary to grow, feed, and reproduce. And it's invisible to the human eye. And for contrast, I put the biggest organism that's ever lived on the planet, and that's a blue whale. which weighs 400,000 pounds. Can you imagine? And it started out as a single cell. All life starts out as a single cell. How did life start? No human being knows the answer to that question. It appears that it began as a single living organism. He had a name, or she had a name, it ends in an A, Luca. I don't know if you know that term, Luca. It's just an acronym for Last Universal Common Ancestor. That is your ancestor. The first, all life is related. Life only appeared once on the planet and has radiated out into this 10 million species of eukaryotic life, which is the large kinds of cells. We have eukaryotic cells, bacteria have prokaryotic cells, but they're still cells. They're not totally different. They're bound by cellular membranes and have complex inner workings. All this arose from a single organism. In all honesty, my favorite subject. Photosynthesis. So, photosynthesis, you know, the word means synthesizing light. Photosynthesis is a process of changing carbon dioxide and water into sugar. It's where all of the food on the planet, that's where the food for all of these organisms comes from photosynthesis. Now, how it arose, it's not known. How photosynthesis arose is not known, but the process is that the sun is able to split the hydrogen atom off the oxygen in water, which is held, you know, with an electric bond. It's able to split it off and transfer it to the carbon dioxide, and what do you get? You get sugar, CHO, glucose. That's where all the biomass on the planet comes from, and it's all like a child of the sun. I mean, the Aztecs might have had a right to worship the sun because that's where life comes from. So this picture of this graduate from MIT is a short video available on YouTube that I recommend, and the title is called Photosynthesis at MIT. And what happens in the video is these guys, they're like graduating in chemistry and physics, and then on graduation day, this interviewer hands him and a couple others hands him a piece of wood and says, well, where did this wood come from? Which is a good question. Where does the biomass on the planet come from? Where do these big ponderosa pines in my front yard come from? They weren't there. They started out as a seed. There's not a hole in the ground. And his answer is dirt. That life comes from dirt. It sucks up dirt. This is a graduate from MIT. They don't learn anything about the most basic dynamics of life on Earth. So where that wood came from is carbon dioxide in the atmosphere. The biosphere is made out of carbon dioxide. About 90% carbon dioxide. It's a stunning fact. Nobody likes carbon dioxide, but everybody likes the biosphere. It's worth pondering. So life has evolved over time. Plant life has evolved over time, and these are a couple of evolutionary steps. It's interesting that nothing lives for too long. Therefore, everything has to reproduce. It has to create these reproduction cells and fertilize those cells and create offspring. And to my surprise, I actually forget exactly how it works with mosses, but with ferns, the male sex cell has a tail, and it swims to the female. In ferns, I guess that's the way it works in mosses and ferns. And then conifers and flowering plants got rid of the tail and used the wind in terms of pollen. So there's numbers down below. Mosses, the scientific name of mosses is bryophytes. It means moss plant. Looking at Erica Heinlein's list, I saw 30 different moss species in Bonaparte Meadows. Ferns, we put the list together, and Julie, I don't know if you remember, but I couldn't find any ferns on our list. And there are 70 flowering plants, and 70 different species of flowering plants in that one meadow. The larger number there is how many flowering plant species there are on the planet. 370,000, which makes them the dominant plant form on the planet. They are the most recently evolved. Ferns and mosses came far earlier, but look how many more flowering plant species there are on the planet than mosses and ferns. So all of the, what was that, 70 species of vascular plants that we cataloged at Bonaparte Meadows all have intricate life cycles and histories, and these are 4 of the willows that we saw at Bonaparte Meadows, and they all reproduce in an interesting way. They produce these catkins. These are the female reproductive structures on all these 4 species. Those are all catkins. The ovaries are down inside each catkin and needs to be fertilized. Well, how is the male DNA, the pollen, going to get there? Willows are an intermediate compromise in pollination. They're largely wind pollinated, but they're also insect pollinated. So they're both. So either the wind or the insect will gather that pollen and carry it to the female reproductive structure, pollinate that, fertilize that egg, and create new, well, seeds to start with. These are a couple of flowers at Bonaparte Meadows. Julie showed that. I don't think she named it, but it's blue-eyed Mary. The purple flower on the left is called blue-eyed Mary. The scientific name is Cicericium septentrionale. Oh yeah, there it is, Cicericium septentrionale. So the interesting thing about those names, they're a little daunting at first, but if you type Cicericium into Google and then type the word etymology, it tells you what the word means. And Cicericium means, so see it has the word rincus in it. Rincus, that means nose. Cicericium means pig's nose. I was shocked to learn that. That beautiful flower means pig nose, and it's because the pigs were if the plant's there and the pigs are there, the pigs will root up, go after the roots of the plant, rooting in the ground with their nose and dig it up. So they gave the name Cicericium, pig's nose. And shooting star fared better. There's a lot of shooting stars. This is one species, Dodecatheon conjugans. Well, the word Dodecatheon means 12 gods. Why? Because the Greeks gathered up these shooting stars and took them to Mount Olympus, where the gods lived. It's just made up. It didn't really happen. But this is where these names come from. That's why they gave it this name, Dodecatheon. They were just imagining that the gods would love this fantastic flower. So these plants have evolved over time to reproduce their own kind, and they don't want to waste any energy. They don't want to waste any pollen. So I don't know that the blue-eyed grass has any particular reproductive pollination trick, but shooting stars have quite a trick. So the dark brown, almost black structures pointing downwards at the bottom of the flower are the male anthers, where the pollen comes out. But the pollen doesn't come out on its own on a shooting star. It has to be shaken out by something. And that something is an insect that grasps the petals with its legs and then vibrates its wings at about, well, it's about the vibration of middle C. I forget exactly what that is, but it's something like 12,000 vibrations a second. And then the pollen pours out of those anthers and onto the body of the insect, who is gathering it up for food to feed its young. It's going to be a bumblebee. Only bumblebees pollinate shooting stars. But in the meantime, the bumblebee goes to another flower and delivers the pollen to another flower. And that little white line sticking out of the very bottom of the flower is the female stigma waiting for the bumblebee to deliver the pollen. Oh, I forgot that was the end. Well, there you have it.
Thank you.
Thank you so much, Dana. I should have mentioned that Dana is the author of the How Naturalist publication, which is a really neat way to learn about the natural world in our area. And also, he helped with the botany surveys that we did last summer at Bonaparte Meadows. As did George Thornton, who decided to come to this event, didn't realize what he was in for. George, thank you so much for being willing to step in. Josh Wozniak helped with these Bonaparte Meadows botany surveys as well and couldn't make it tonight, and we weren't able to get the Zoom going, and so George is going to step in. George has a tremendous amount of experience here in the Okanagan, looking at rare plants all over the place, and has really been a mentor to me in terms of learning the botany of our area. So thank you so much for everything you've done for the natural resources in our area, George. And please welcome George.
Yeah, I'm, as introduced, I am George Thornton. I was born and raised in Oroville. Do I have to? Yeah, and I was talking to kids, and so I lost my teacher voice over the years. Anyway, is that better? Yeah. Okay, thank you. Anyway, I grew up in Oroville, lived there for about 65 years, and moved away 2.5 years ago. And we owned 40 acres. It just getting too much for me physically, and I really needed to come back for good reason and see old friends, and that's why I came tonight. Then Julie drafted me. But anyhow, I was in on one of the first surveys on Bonaparte, and you can see what the peat looks like there. And the big thing about the peat is it's all the vegetable matters, and Dana's talked a little bit about that accumulates after a very long time. It only happens to accumulate if it's not rotting, which makes a lot of sense. Well, and the reason why it doesn't rot in this fen or in this particular meadow is there's so very little oxygen below the surface. And and what does that is because the water normally carries a lot of oxygen in it, but because it doesn't flow, what things are there pull the oxygen out of it very quickly. So if you don't have rapid water flow, and you have a lot of plant growth, you develop these very deep, thick layers of peat. And that's why I'm here. Well, the uniqueness, which has already been spoken to, is this is even more unusual. It has the slow water flow. It additionally has this very alkaline nature to it. And that's for some reason, and you have to go back to geology, which I don't know a whole lot about, but there's a whole streak of underlying limestone from somewhere down towards, Mount Ann, and then up north through this area and then all the way up to the Canadian border. Those are only the areas I've worked in. I don't know if it extends farther in either direction. Most likely it does. And any time you get the appropriate geology in that area, you'll get this development where you'll start finding this, what are called calcareous fins. Some are tiny. And I've been with Joe Rocchio and others to some very tiny ones. And this Bonaparte is so much larger and more complex because of the huge size of it. Well, the other thing that leads into this, and I'll try to be as quick as possible, that you get this huge accumulation and rapid plant growth and low oxygen levels, and the calcareous nature creates this much more unique botany habitat. Well, why doesn't it just erode a channel at the east end and the water flow out? Well, periodically we get, what happened a couple years ago up there? Do you remember that big landslide? Periodically we get big rain, big floods, snow melts, and you get these big slides coming off of Mount Bonaparte. And up top of Mount Bonaparte happens to be a lot of volcanic ash, so it flows very easily. And that blocks periodically that exit out of the east side of the Bonaparte Meadow and continually replenishes that plug that keeps it from draining. And so multiple times over millennial years, this would happen again and again and again. maintaining this relative level water level, and we build up a deeper and deeper bog over time. That's why this one is so big compared to all the other little ones scattered around this course of limestone that you find up this vein running up and down this part of the area. Well, okay, peat moss. Let's see. Get this thing. Okay, we'll get to it. This is peat harvest in the British Isles, particularly this in the Falkland Islands, which is really far and south. So you just take out, you can see the shovel on the side. They take this very long, narrow shovel, and you get these, and then lay them up on top of the ground, and it'll dry over the months. Sometimes things get put in the bog, and they also get preserved. This is a famous person. Nobody knows his real name, but he's in somewhere in a bog from, I believe it was the Netherlands, actually. Okay, there's a typical peat area. You can see the hummocking. That's fairly common also. That's these what we call hummocks. And then you've got the water courses that drain out between them. You've got various heather-like plants. This is typical. This is not boulder. This is typical kind of peat. It's on a slope, so it's not going to develop deep because it's continually water's flowing off. So it's not going to get as deep as you can get in the Bonaparte fan. Could be any number of places, Dan, because it's pretty common with that look to it. And yeah. So here's a harvest from way back. I went into some houses in the Hebrides and out of the west coast of England, and they all lived back then in what they call black houses. That's because when you burn peat, I should say, it's just smolders, makes heat, lasts a long time, but you're living at about the bottom 3 feet, and because the smoke is in the top part of your house, and so people did get very dark, and everything you had got very dark. Okay, more harvest. They'll cut them, lay them on the side, cut them, lay them on the side, and then work their way up the hill. When I was in the Hebrides, I asked, how long does this replenish? Everybody would look at you, we don't know. And so the replenishment process, the rebuilding process that will take, it's an open-ended question. Julie, do you have an estimate?
1,000 years.
1,000, it's a big number.
It's going to form at about 1 millimeter per year.
Yeah. So and we've been harvesting it since the 20s at least. And you can see that there's been a lot of reduction. But it can do it, we can do it. And more of the peat harvest, peatlands and other places. There's the burning of it. The places I saw, it was smolder, but this must be really dry. That's the only thing I can say. And where I was in the Hebrides, it never gets dry. The price, you can still get it for this price? It seems cheap. Okay, there's the harvest up at the meadow. You can see where they dig it out and they make piles and load it up in the primary use lately has been used in production of marijuana. It's great for that make up pots that they grow the plants in. Okay, they scrape off the topsoil, start letting it dry it out, and when you can get it dry enough, you get out there and haul it in. There's a good view. So you can see this is a Bonaparte Lake, and you can see it runs down here. There's slides that are happening, are coming down off of, underneath the legend and down the hillside here, and you can see this white. That's that stuff that's come down off of that Bonaparte periodically and blocks the area. I never knew about that. I've been here for a long time, and those are the first slides I ever heard about was in the past 5 years. So it doesn't happen often, but it's part of the process. And then there's your nice view of the fen. That's looking to the north, I believe. Yeah. So Bonaparte Lake is in that narrow part at the top. One of the interesting things is, even in the watery areas, we were out looking there and we started finding some rare plants. And these are disturbed areas, so rare plants will come back fairly quickly if left alone. It doesn't take a lot to give the opportunity. And you can see that in a lot of places. You maintain the habitat, the plants will come back. And I don't know how, is this the triloca picture? Yeah. Somewhere in here, yeah, right there. That is one of our rare plants, Trilocan palustris. And it's called arrowgrasses by another name. And we're only finding it in these calcareous fen areas. And more. And these are some of the willows. It's on the closer to Bonaparte Lake itself. We started hunting through here. And Dana, what species did we find here that were unusual?
Salix macellania, McCall's willow, and Salix brachycarpa, willow.
Yeah, and you know, right offhand they don't look a lot different, but you notice a slight more gray color here and here. You can see some of the head top shapes are different. So there's little clues that we're dealing with a mixed species in this little grove. So you walk into there and you just say, okay, what clues is it giving me as to where I should look first? And another look. And your coltsfoot. You go to the west side, coltsfoot is an entirely different plant. You know, it's just, didn't even recognize it to be the same thing. And there goes Josh himself. And I'm sorry he couldn't be here. He would do so much better than I. Okay, any questions? We want to get all the experts up here, and maybe you have a question or two.
Are there areas where you would think, areas where the simplifier you can become a bomb person?
Where my best guess is that where they harvest, and that's going to be down here, and it would be where it's harvested because it's pretty mucky. And the assumption is that the people in wherever it was, Denmark or the Netherlands or whatever, they dug into a shallow grave, buried it up, and then the bog into the rest over time. And of course, you get that tanning action that happens fairly quickly. So you have a different complexion over time.
Everywhere we walked where there was vegetation, we did not sink down, but we didn't try walking in the harvested areas. But there is a calcareous fen uphill from this one where people have fallen in. It is something you have to be careful because it feels like ground, but really you're just walking on a bunch of vegetation with water under it, and you can, in some cases, fall in. So do be careful if you're in a fen.
Yeah, this place that Julie's not talking about, it does have some floating areas on it. And there is a spring on there that is the source of this somewhat alkaline water. And where this pool comes up, it's clear. And someone who got to the name walked over there to look in it, and he slipped it down this hole. He didn't drown. People had to haul him out. So there would have been little windows into the underground where the springs are that actually are bubbling up the slightly alkaline water.
Another question, Andy?
Yeah, are there any state or federal regulations in play that would help protect the wetland?
Yeah, are there any state or federal regulations at play that would help protect the wetland? Yes. So going forward, if a landowner were to want to initiate peat extraction from this wetland, there would be regulatory involvement in deciding whether or not that would go forward. And this is a Category 1 wetland. That means it's not replaceable. We can't recreate it somewhere else. We have to have all the unique conditions as they are in order for it to form and to exist. And so my understanding is it would be very challenging for somebody to initiate a new operation, given how special this wetland is, due to the regulatory process involved. I'm not a regulator. Sorry?
How about building on it?
How about building on it? Yeah, so originally there was a permit from the Army Corps when Jack Jones bought the property, he was permitted to remove the peat, build a dam, make a lake, and put cabins all around it. That was the original vision.
What year was that?
That was in the 70s, yeah, mid to late 70s. And it was permitted at that time, but fortunately it didn't occur.
I'm sorry.
Move his hand.
Okay.
I have 2 questions. Would that permit be transferable if somebody did purchase it?
No.
Oh. And Julie, can you just briefly talk about what a vision for restoration would look like, since we have that nice picture up there?
Yeah, thank you. So we're still working on that as a team. You know, we're very early in on the process of thinking about what restoration would look like. The most important thing is to slow the flow. Whoa, I just got really loud. To slow the flow, because right now we have the straightened channels are down here at the south end, and water is, the water table, like I mentioned, had been lowered, and then water is being really quickly moved off of the site. So we want the opposite to happen. We want to be able to stop the water from leaving the site so quickly, to slow it, and we want to raise that water table back up. What that's going to look like hasn't been determined yet. So we will go through a restoration planning process, and we're writing a grant right now that's due on Monday that will include some restoration planning funding to help us with that process. We have a lot of collection of data that we still need to do on the site to better understand what's happening right now so that we can come up with a plan of what to do to restore the wetland. So there's a number of different options that will be considered.
Looking at this picture, it looks like there's conifers that are heading moving in current water conditions along the sides towards the interior of the bed. As the water table is raised, what kind of changes do you anticipate to happen to the conifers and the other plants, the willows and shrubs that might be under the ground as the water?
Great question. So Michelle was pointing out that as the water table fluctuates, the vegetation community responds, and so we're seeing trees that are maybe encroaching into the fen where they may not have in the past due to the lower water table. But when we do raise the water table as part of the restoration, the question is what would we expect to happen with those conifers and maybe some of those other species that are not adapted to that higher water table. What I've seen happen in the past, for example, at Lost Lake, when the beavers got really active around 2010, 11, 12, 13, we saw the bog birch die because it wasn't used to that high water table. And that's part of what happens in these systems, that they're dynamic. They're not static. They don't stay the same over decades, right? And so as the water table comes up, some species that aren't adapted for that will die back and allow for other species that are adapted to those higher water tables to flourish. And it's easy as humans for us to feel uncomfortable with those changes, right? Just like when we see a pond that we love, it starts to have more vegetation and more vegetation. We're like, no, but I love my pond, I don't want it to fill in, but natural succession. Things are always changing. And so it's important for us to be open to the dynamic nature of the world so that we can support those functions that we need.
You mentioned the current restoration that you're working on. That's land that's already been acquired from private owners?
We have not started restoration yet. I mean, when I mentioned doing restoration earlier, that's what I do for a living. And so lots of different properties all over the region are being restored. Some of them are private lands, some are public lands. Griffin is here, Alexa, other folks who do restoration, Jen, Chevelle. We always look for opportunities on all different kinds of land ownerships.
So all this land around here is privately owned currently?
A lot of it is public land on the west side and the north side, and then wrapping around the top of the east. That is all public lands. It's DNR and U.S. Forest Service. And then there's private land on the east and around the south end of the property. Yeah. Lee?
Yeah, my memory of that area, because I lived up in Wakanda for about 50 years, was before they dug those channels to drain the water off there was not lakes everywhere because the water table was, 10, 15, 20 feet higher than it is now, because the water was contained within the peat. And my assessment, just being an ignorant regarding these things, is if you block those very little noticeable difference in those lakes out there. I think that peat will retain that. That's just what I have to say because I observed it for all those years.
Thank you, Lee. I hope people could hear what Lee said. He's been observing the site over the last 50 years and has noticed that it has changed a lot when the channels were dug. And I hope I'm paraphrasing correctly. There's a lot more surface water now than there used to be. And then as it becomes restored, it may be that we don't see that much surface water as the peat is again able to hold the water below the surface. Is that a fair paraphrase? Thank you. Yeah.
Well, first I had a comment mainly about your landslide. So that was specific due to the fire and the hydrophobic soils, and maybe not common to that area, but it's common to this area in general. It happens very cyclically. But my question was, could you kind of elaborate on what you said about the Canadian lynx? Because from my understanding, they like very covered habitat, especially in winter. And the snowshoe hares are primary food source, and they also need that 8-foot cover over snow, or 8 feet, over 8 feet. And so.
Thank you. So this conservation acquisition is 745 acres, some of which is open wetland and some of which is upland forest.
Okay.
And so my understanding is that throughout that mosaic, that there would be opportunity for Canada lynx to find some of the forage, some of the food and shelter that is needed. But I am not an expert on Canada lynx. That's something that was mentioned to me by a biologist. If anybody wants to chime in, please feel free if you have more expertise.
Okay, I can increase.
Any other questions? I know there were some questions about the campaign and the fundraising piece too, and I want to circle back to those. But question at the back.
Are you gonna do a Kickstarter online for people to nationwide fund your efforts?
We don't have a Kickstarter, at least at this time, but we have a dedicated fund where people can donate online. And so we're just now ramping up our outreach, like this event right here, letting people know what's going on. We are working on videos about the project that we can put on social media, where we can direct people to that website where donations can be made. So there's a dedicated account that's part of the Okanagan Land Trust website, and it's an account that the Land Trust is holding that people can dedicate specifically funding for Bonaparte Meadows. And so if you use Instagram or Facebook or YouTube, what have you, TikTok, if you go to Beaver Food Forest, that's my account where I post about Bonaparte Meadows and other restoration work. And then the Okanagan Land Trust account as well on Facebook and Instagram are places where you can keep yourself tuned in with how this is all going, find out what's happening, and also support this effort.
I'll just add, if you are not already on OLT's mailing list, that is one place where we'll be sending out information, updates, event announcements, and so forth. We have a sign-up sheet over there, so if you're not already on that list, or if you are on our mailing list but you want to be added to like the special Bonaparte Meadows updates where we might be sending things out more often, we try not to send a ton of stuff out through our regular mailing list, but if you want to know every new development that we have to share, you can make a note of that on the mailing list over there, and we'll add you to that kind of updates list. And so you can make sure to know that we have, as Julie mentioned earlier, some very cool opportunities in the planning stages to get people out on the fen, in the fen, and really experiencing it, including some of those amphibian, insect surveys, bird surveys, geology field trip in the planning. So all of that we'll be sharing with you as soon as we have it planned and ready to go, and look forward to seeing you out there. Oh, yes, and probably some very special musical opportunities, but I can't say too much about that yet. There were, I think, some questions about the fundraising aspect of things in the campaign. Did folks want to ask any of those questions? I can say just quickly, there is a handout that you can take, a single-page handout that has a QR code. It links to the landing page for this campaign on our website. That gives you more information, including about ways to donate. You can donate digitally, electronically on our website. You can do it the old-fashioned way by sending us a check and just noting that it's for the Bonaparte Meadows campaign rather than for our regular fundraising purposes. Or you can contact us through the contact information that Julie has shared and that's there on that webpage if you have more ambitious or complicated ideas for how your gift might be used. So those are all ways that you can support the campaign. And we have t-shirts, beautiful t-shirts designed by our amazing designer, all-purpose marketing expert, Chinook Devereaux. They're gorgeous. They come in a bunch of different colors and sizes, and all proceeds from merch sales support the acquisition effort. So that's another thing you can do too. And when people ask you about your t-shirt, you can tell them all about it after tonight. Kevin wants to say something as well.
You can also donate back here.
Yes, we have a square
right now.
thing set up over there too. Were there other questions about the fundraising? Oh, okay, great.
Thank you all for being here. I hope that you will support us in protecting Bonaparte Meadows and stay involved and let us know if you want to be a part of any of the events that we have out there. Thank you for coming.
Thank you so much.